Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is M.Nizamuddin bin Jaafar Husni. I'm from BMMP and my title for PSM is the study of physical and environmental characterization of Sago starch mixture with glycerol. First of all, I would like to thank you to my supervisor TS Dr. Nazri Huzaimi bin Zakaria for guidance and supporting me during my PSM. Also, I want to thank you to Internal Evaluator 1 TS Dr. Omar bin Bapuguti and Professor Madia TS Dr. Zulkifli bin Muhammad Rosli for evaluating my report presentation. Chapter 1 Introduction. Okay, according to Alvarez Chavez, plastic materials are widely used and important materials due to their characteristic and performance. And Ahmad 2011 say many researchers have pointed out the plastic trash contribute to environmental issue. Also, according to Ahmad, thermoplastic starch is a great resource to use cause contain more than 70% starch and material with good characteristic and biodegradability. Sago starch is also regarded as the most essential raw material. Thus, this research is under research and development. The goal is to study the physical and environmental characterization of sago starch mixture with glycerol. Problem statement. Non-degradable plastic can lead to waste disposal problems, according to Ismail 2016. To counter this issue, bioplastic development is needed. In this research, thermoplastic starch based on sago starch mixture with glycerol. Then, sago starch from the sago palm make it easier to gelatinize, extremely viscous, non-toxic, and biocompatible. However, due to their hydrophilic nature, starch-based material have a low moisture barrier and other. Therefore, to increase interfacial adhesion with sago starch, glycerol was used as a plasticizer. Okay. The objective of this research is to fabricate sago starch, to investigate the properties of physical on sago starch mixed with glycerol, to find the properties of environmental on sago starch mixed with glycerol. Scope of research, as you can see, thermoplastic starch sample out of sago starch and glycerol mixtures. Sago starch powder contain 25% amylose and glycerol 95% purine. The ratio of glycerol as shown such as 10/90, 20/80, 30/70, 40/60 and 50/50. The sample will be poured into a mold. Then the resulting product will be cut into the 5 sample. Literature review. Literature review basically a review is an overview of the previous published works on physical and environmental characterization of sago starch mixed with glycerol. So I refer the literature review on Google Scholar such as article and books. Okay, and go through with the starch. Okay, sago starch. Sago starch is a type of starch that is commonly extracted from the metroxylin sago palm. According to Du 2020, he say sago starch gel had the highest hardness, adhesiveness, springiness, and cohesiveness, that suggesting that they could be used as the stabilizer. Sago starch also is processed for direct food consumption, also through biocomposition such as bioplastic. So this is the sago starch process from the beginning until they making the starch. Alright, next, plasticizer agent glycerol. A plasticizer is a substance that is applied to another material. According to Lee and Co. 2012, he say plasticization is the process of altering a polymer structure to make it more bendable. Also, plasticizer glycerol improve the ability of bioplastic to absorb water and acts as a crystal forming agent. So according to Thomas Zing 2005, he say due to the stronger plasticizing impact of glycerol, an increase in the proportion of glycerol result in a drop in the tensile strength, modulus of elastic, and increase the inhalation at break, and water vapor permeability. Sago starch based bioplastic plasticizing with glycerol. So according to Nazri and Worldary 2021, he said because of starch contains so many intermolecular and intramolecular hydrogen bonds, it is not regarded as a true thermoplastic. So to supporting this, another citation, Quintana 2008. It say unplasticized starch is brittle. Adding the plasticizer, which is glycerol, will reduce tensile strength while increasing inhalation at break. So this is show that this is because of the plasticizer interfere with the polymer chain sliding, will increasing the filament flexibility. Chapter 3, methodology. So basically the overall plan and rationale of a research effort is referred to as methodology. So methodology is the idea or principle that support in order to design a strategy that is aligned with our objective. Okay, so this is the my process flow charts, starting with literature review. Next go to raw material selection and material preparation with a sago starch mixed with glycerol, and then make the material fabrication, and then we'll make the experiment testing to identify the properties of physical and environment, and then gain the result and discussion. Okay, raw material. We use sago starch powder, which is 25% amylose, and glycerol 95% purity with a density of 1.261 gram. Okay, so the material preparation and fabrication. The thermoplastic starch combination and glycerol must be weighed using a particular type of ratio. So we use a ratio glycerol over sago starch, which is 10/90, 20/80, 30/70, 40/60, and 50/50. So the mixture was then weighed again on digital scale before being poured into a mold with dimension of 140 multiplied by 60 mm. The mold will be placed in the hot press machine after the mixture has been prepared inside the mold. The mold is then hot pressed for 15 minutes at pressure of 25 kg centimeter square at a temperature of 165 degrees Celsius, and then followed by cooling for 15 minutes. The resulting product will be cut into 5 sample static size, which is 10 multiplied by 10 multiplied by 3 mm using a table saw cutting machine before being tested. So this is the mold case and hot press machine. Alright, so the environment method, due to the physical and environmental characterization of sago starch mixture with glycerol, is we use density, moisture content, water absorption, soil barrier, and water solubility. Okay, for density, the standard we use is ASTM D792. This method are used to assess the average density or specific gravity of a bigger sample or product by evaluating the physical change in a thermoplastic sample. So the weight of 5 samples will be taken, we known as W1, then hang the sample inside the container that filled with water, and then weight will be taken, also known as W2. So this is the formula according to Nazri and Worldary 2021, density W1 over by W2. Okay, moisture content. The moisture content of the thermoplastic sago starch sample is using ASTM G2170 according to NISA 2019. We put the sample in a hot air oven at 105 degrees Celsius, and then we put the sample in the desiccator. And then by using this formula, the percentage of moisture content can be determined by Sarifuddin 2013. So this is the density apparatus. We have regular balance, we have hot air oven, and desiccator. Okay, water absorptions. So we use ASTM D570. So according to Nanda, in 2013. Each of sample will be weighed by using weight and soaked in the normal water for a day, 24 hours. Each sample will be weighed in direct condition to see the water absorption comparison before and after soaking. So this is the formula of water absorption to get the percentage. Soil barrier. Soil barrier or SBT is 5 thermoplastic sago starch sample by using ASTM to G to 1. So we will take a weight of 5 sample will be taken before the soil test. After that, a sample will be buried under the soil for 10 days. So this is the formula of SBT to get the percentage. So water solubility. So we use according to Louisiana, we use ASTM D570. So the sample remaining section will filter. The sample will be next be dried in a hot air oven at 105 until final weight is determined. Before that, we will submerge the sample in the 100 mm distilled water for 6 hours. So this is the formula how to calculate the percent solubility of water solubility. Okay, preliminary result. So this preliminary result is the expected result can be found in the previous result findings that are almost the same. Okay, so this is the density of previous result according to Nazri and Woolery 2001. Based on sago starch containing betel, the maximum density value of 1.515 gram was found with a 30% glycerol addition variation. The density value is increased by adding glycerol. So as you can see, the graph is achieve height at 30% glycerol. Okay, moisture content previous result according to Lai 2030. So you can see this is the individual component analysis due to glycerol and sago starch. We can get glycerol 0.68% and sago starch 15.14% of moisture content. Okay, water absorption previous result according to Nazri and Woolery 2001. Water absorption in starch-based bioplastic has a substantial impact on the bioplastic properties and features. According to this graph, as a result, research into the potential of bioplastic to absorb water is required. Bioplastic with a 30% glycerol variation had the highest water absorption value with a 75.62% water absorption percentage. Okay, so barrier. Based on NISA 2019, it said the hydrolysis group in starch will initiate the hydrolysis reaction of the polymer after absorption water from the media, while glycerol, a hydrophilic plasticizer, effectively reduce internal hydrogen bonds in the polymer change, resulting in a decrease in bioplastic residual mass and increase in biodegradability. So this is the graph of the weight loss of starch bioplastic after 10 days test. Okay, water solubility. So according to Mizura, this is the graph that present an absence of glycerol and effect of non-glycerol. So you can see the black one is with glycerol 30% and the white one of the graph is with 0% non-glycerol. So you can see that the percentage of water solubility of adding glycerol is high than non-glycerol. Okay, summary is the goal of according to Louisiana, the goal of biodegradability research is to determine how long bioplastic take to decompose in the environment. So sago has the potential to be resource of starch-based bioplastic due to its high carbohydrate and amylase content. So therefore, sago starch glycerol is the great option to plasticize with the thermoplastic sago starch. Hence, sago starch mixture with glycerol is one of the best alternatives for making biodegradable plastic sample. So thank you very much. If you have any question, please don't hesitate to contact me. Thank you very much.